Hello everyone, my name is Avazbek Anvarov. In this video, we're going to talk about the confidence interval for a population mean. And my helper, my AI assist James, gonna teach you everything in this video. So here we go.
Welcome. In this video, I'll be constructing confidence intervals for a population mean, assuming the population standard deviation is known. A confidence interval constructed from sample data is a range of values that is likely to include the population parameter at some specified confidence level. The confidence interval for a population mean is determined by taking the sample mean, the point estimate, and subtracting and adding the margin of error to it. So if the population standard deviation is known, the margin of error is determined by Z alpha over 2 times sigma over square root of n, where alpha, the significance level, is 1 minus the confidence level, and correspondingly, the confidence level is 1 minus alpha. So if the confidence level is 95%, alpha will be 1 minus 0.95, which equals 0.05. Z alpha over 2 here is a single value called the critical value. It can be found in the normal tables or by using software. When constructing a 95% confidence interval, for example, the confidence level 0.95 is in the middle of the distribution, and the remaining 0.05 alpha is divided equally into the two tails as 0.025 each. From the less than cumulative standard normal tables, 0.025 in the left tail corresponds to a Z value of negative 1.96, and due to symmetry, it will be positive 1.96 for the right tail. So the Z critical value corresponding to the 95% confidence level, which we write as Z.025, is 1.96. Let's look at an example. Scores on an exam are normally distributed with a population standard deviation of 5.6. A random sample of 40 scores on the exam has a mean of 32. We want to construct confidence interval estimates for the population mean at 80, 90, and 98% confidence levels. The margin of error is going to be Z alpha over 2 times 5.6 divided by the square root of 40. We now need to find the critical value for each confidence level. For the 80% confidence interval, alpha is 0.2. So we have 0.1 in each tail. Looking up 0.1 in the normal tables, we find the closest value to be 0.1003, and that corresponds to a Z score of negative 1.28 in the lower tail. And because of symmetry, it is 1.28 for the upper tail. So the Z critical value for the 80% confidence level is 1.28. The margin of error is therefore 1.13. So the lower limit of the confidence interval is 32 minus 1.13, which gives 30.87. And the upper limit is 32 plus 1.13, which gives 33.13. To interpret that, we say we are 80% confident that the population mean score is between 30.87 and 33.13. With 90% confidence, alpha is 0.1, so we have 0.05 in each tail. Looking that up in the Z tables, we find that 0.05 lies exactly midway between 0.0505 and 0.0495 here. That is between Z scores of negative 1.64 and negative 1.65. So we average the two values to obtain negative 1.645. And so the critical value is 1.645. And that gives us a margin of error of 1.46. The lower limit of the 90% confidence interval is thus 30.54, and the upper limit is 33.46. The 98% confidence interval has 0.01 in each tail and has a Z critical value of 2.33. So the margin of error will be 2.06, the lower limit will be 29.94, and the upper limit 34.06. From the results, we see that as confidence level increases, the critical value Z increases, the margin of error increases, and consequently, the confidence interval became wider. And that's it for this video. Thanks for watching.
So thank you for James to explain all of it. Thank you for watching this. So goodbye.